Good morning students, how are you? Hope you are all in the pink of health. I am Atanu and you are watching Bond Making and Bond Breaking channel. Today I am going to discuss with you about the introduction of carboxylic acid and its classification as well as its general common simple IUPAC nomenclature. So let's go with optimistic energy. So let's go. First of all, what do you mean about carboxylic acid? So the carboxylic acid means it has ketone, this group, carbonyl group, okay, and as well as you have this OH group, that is hydroxyl group, CO carbonyl group and hydroxyl group, then you get COOH, that is carboxylic group. So carbonyl group and hydroxyl group gives you the carboxylic product. Okay, this is the basic concept, and the structure of carboxylic acid is written in this way. So this is the way to write the structure of COOH. Now the classification. Classification 1 is according to the presence of COOH group. Okay, according to the presence of COOH. So one is mono carboxylic acid. So what do you mean about monocarboxylic acid? That means CH3COOH, the number of COOH equal to 1. As the number of COOH equal to 1, this is called monocarboxylic compound. Okay, then dicarboxylic compound. Dicarboxylic compound means you can get COOH on the same carbon. So the number of COOH equal to 2, that is why it is called dicarboxylic compound. And you may write in this way, or you may represent in this way, CH2CH2 and COOH as like Vic or Vicinal, and it is like gem, that is geminal. So this is dicarboxylic group compounds due to the presence of 2 COOH on same carbon or different carbons. So this is called dicarboxylic acid. Okay, or you can write in this way also, COOH and COOH. This is also dicarboxylic group. Okay, the name of this compound is oxalic acid. What I said? This is called oxalic acid. This is called oxalic acid. So if the number of COOH equal to 1, this is called monocarboxylic compound. If the number of carboxylic 2, if it presents on a carbon or different carbon, or in this way, oxalic acid or this type of groups are called dicarboxylic compounds. Okay. If it presents in this way, CH2COH, CH2COH, this group is called succinic acid. So succinic acid, oxalic acids are the examples of dicarboxylic compound. Okay. Now, thirdly, if you write CHOH, COOH and COH, the number of COOH number of COOH equal to 2. As the number of COOH equal to 2 means the number of carboxylic compounds 2. So this is called this is called also dicarboxylic compound. Dicarboxylic compound. Okay, this is also called dicarboxylic compound. So this is the example of tartaric acid. Okay, this is the example of tartaric acid. Okay, so what is the basic idea that I want to give you? If the number of carboxylic compound, on acetic acid or formic acid, if the presence if the number of COOH equal to 1, if the number of COOH equal to 1, this is called, if the number of the presence of COOH, if the number of COOH equal to 1, that is called monocarboxylic acid. Or if the number of this is called monocarboxylic acid, I say monocarboxylic acid. Okay, this is monocarboxylic acid. If the number of 2, that may be on succinic acid or oxalic acid or tartaric acid, the presence of COOH equal to 2. What I say, this is oxalic acid, as you know. Finally, this is oxalic acid, so the number of presence of COOH equal to 2, that's why it is called dicarboxylic acid. Or you can write in this way CH2COOH or CH2COOH. This is also the number of COOH equal to 2. That's why succinic acid is also called a dicarboxylic acid compounds. It's easy fact. And now if you write in this way CHOH and then COOH, and you also write CHOH COOH, so you get this oxalic acid, what is dicarboxylic acid, and then you take this succinic acid, it's also a carboxylic acid. Then you take tartaric acid, it's also a dicarboxylic compound due to the presence of 2 carboxyl groups. Okay, it's very easy. So the third one, so the number of if the number of COOH equal to 3, that is called tricarboxylic compound. Tricarboxylic compound. It may be CH2 and then COOH on this position, or you can write COOH in this position and COH. So the number of COOH equal to 3. So as the number of COOH equal to 3, it means it is tricarboxylic compound. Okay, so this is called carboxylic acid. Okay, what do you mean? 1, 2, 3. So 1, 2, 3 tricarboxylic propane. Okay. Now you can write this IUPAC name in this way: propane 1, 2, 3 tri. 1, 2, 3 propane 1, 2, 3. So as the number of carbon 3, this is called prop. As the bond between them single, then called N. So this is propane. But the position of COOH equal to 1, equal to 2, and as well as equal to 3. So as the number, as we should write the number of the COOH or the position of the COOH, that is 1, 2, 3, and the tri means this is tri group. So tri carboxylic acid. So this is the propane 1, 2, 3 tricarboxylic acid compound. Now you can take another examples. if you take in this way, CH2, that is COH, and then CH, that is also COH, and then you can write CH2, then CH2COOH. Then the position of this carbon, 1 2 3 4, that should be 1 2 3 4. So the number of carbon equal to 4, so this is butane, this is called butane, and then the position of the COH equal to 1 2 and 4. So 1 2 and 4, the number of COOH equal to tri, so this is tri, butane 1 2 4 tri, and this is the carboxylic group, so this is carboxylic acid. So this is carboxylic, you should write in one line, so this is carboxylic acids. So butane 1 2 4 tricarboxylic acid. Okay, now I give you another examples. If you have CHCOOH, then CH2OH, then CHCOH. This one, this is as the number of this carboxylic group, COH, and you should write another COH from here, COH. So as the number of COH equal to 3, so this is also a compound of tricarboxylic group, tricarboxylic compound. Do you know its name? Its name citric acid. Okay, it's a citric acid. This is citric acid. So citric acid is the example of tricarboxylic compound, and the succinic acid or the oxalic acid or the tartaric acid are the examples of dicarboxylic compound, and acetic acid, formic acid are the examples of monocarboxylic compound. Now let's talk about alpha, beta and gamma compounds. So this is CH3, CH, COH. So 1 2 3, you can write this is bromine, or you can have 1 2 3 4, and you can write in this way OH. So the carbon behind the COH is called the alpha carbon, and then the beta carbon, and this is called gamma carbon. Should be remembered. What do you mean about alpha carbon? Alpha carbon means that just behind the COH group. In this case, just behind the COH, it's called alpha carbon, and then that carbon is called beta carbon, and that's behind the carbon is gamma carbon. So this is the simple. And now take some examples of IUPAC nomenclature. So let's start some IUPAC nomenclature. So firstly, CH3COOH, it's very essential, as we know everybody. So as the number of carbon 1 and 2, so this is called eth, and this is carboxylic acid, that's mean weak acid. So or it's 1 weak, so ethane 1 weak acid, so you can say it ethanoic acid. So this is ethanoic acid. As simply, if you write HCOH as the number of carbon is 1, so as the number of carbon is 1, so this is called methanoic acid. So this is called methanoic acid. Okay, as the carbon is 1, that is called meth, and the bond between them equal to single, so this is called that is methanoic, and this is weak acid, so this is called methanoic acid. As the carbon is 2, so this is called eth, and the bond between them is single, so this is called ethane, and the presence of COH, that is carboxylic group, and we call it weak acid, so this is ethanoic acid, and as it is called for methanoic acid. So these are the two compounds which is very essential for the chain reaction as well as for the any other questions, you should mention the name, and this is called methanoic acid, or you can write it's formic acid and it is ethanoic acid. You can call it the general name of this compound is acetic acid. So it's two common, important and easy compounds. Now you take another examples of, you can take another examples of CH3 CH2 COH, right? So third one is CH3 CH2COOH, that is means carbon between this group are carbon, the number of carbon is 3, as the number of carbon is 3, that is equal to prop, and the bond between them single, so this is propan, pro plus n, that is an propan. What do you mean here? Propan, propan means propane, prop 1, prop means 3, number of carbon 3, number of carbon 3, so that is prop, and n means the bond, the bond is single, so the this is called propane, and then 1 weak, and O is the vowel, so you do not write this E, so this is called propan 1 weak acid, so you can write it propanoic acid. So the compound is, propanoic acid. Okay, so the compound is propanoic acid. So this is called ethanoic acid, methanoic acid, and then you take propanoic acid. You got it? Okay, next take more examples. Then propanoic acid, then butyric acid or butanoic acid, that is CH3 CH2 CH2COOH, as the number of carbon 1 2 3 4. So as usual it is called butan 1 weak acid, so this is, you can write it butanoic acid. Okay, write it the name butanoic acid, butanoic acid, butan, due to the presence of carbon 4, butan, and the position of the COOH and the position of the COOH 1, so butan an means N, and an represents here the bond between them single, so butan, and the position of COH is 1, so butan 1 weak acid, so you can write it butanoic acid, or you can write butyric acid or N-butyric acid. The general name of this compound is N-butyric acid. Okay, N-butyric acid, or you can write its common name, so you can write its IUPAC name, that is equal to butanoic acid, that is equal to butanoic acid. Okay, butanoic acid, you can write N-butyric acid. So you learn from here, so methanoic acid, ethanoic acid, propanoic acid, and this is the butyric acid and or butanoic acid. And next one is valeric acid. What is it? Valeric acid. Simple. Valeric acid means CH3 CH2 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 COOH, and 1 2 3 4 5. So this is pentanoic acid. Pentan. Pent means the number of carbon 5. As the number of carbon 5, this is called pent, and the bond between the carbon is single. So this is N. Pentan 1 weak acid, due to the presence of COH equal to on the first position as the number of 1. So as the position of the COH equal to 1, that is called pentan 1 weak acid, or you can write smartly pentanoic acid. Okay. So this is pentanoic acid, and you should know the compound. This is called valeric acid. Okay, this is valeric acid. So this is valeric acid, and now isobutyric acid or 2-methyl propanoic acid. So the next one is 2-methyl propanoic acid. What I say? 2-methyl propanoic acid. 2-methyl propanoic acid. So 2-methyl propanoic acid means this is CH3 and C 2-methyl, so this is CH3 propanoic acid, and then COH. I hope so. Okay, so this is called 2-methyl propanoic acid. 2-methyl as 1, 2, 3. So 2 methyl means the methyl group on the number 2 position, and the propan means 1, 2, 3, the number of carbon. Propan means 3, and oic acid means the COH should be present in this compound. So this is called 2-methyl propanoic acid. Okay, you should write 2-methyl propanoic acid, or you can write it, or you can write it isobutyric acid. What I said, this position is called iso position. So you can write isobutyric. This is the general name, isobutyric acid. Hope you understand. It is called isobutyric acid, as well as its IUPAC name 2-methyl. The position of this carbon 2, so this is 2-methyl propanoic acid. Propanoic acid. Propan means the number of carbon 3. So this is called propan. And oic acid. Oic means COH. So propanoic acid. Okay. So let's go for the next example. Let's go for the next example. I take palmitic acid. Palmitic acid. This is CH3, CH2, the number of CH2 14, and then COH. What's the name of this compound? Palmitic acid. Palmitic acid. Okay. As it named palmitic acid, you can write it hexadecanoic acid. This is called hexadecanoic acid. Should be remembered, hexadecanoic acid, or the general name is palmitic acid. So this is called palmitic acid. Okay. Okay. Palmitic acid and hexadecanoic acid. Now take another example. It is 16, CH3, CH2 16, and then COH. This is called stearic acid. This is called stearic acid. Okay. So stearic acid, or you can write it octadecanoic acid. Octadecanoic acid. So palmitic acid, stearic acid. Now take more examples. Now you can write CH3, CH3, CH2, COH. 1, 2, 3. 1, 2, 3, 4. So 3-methyl butanoic acid. 3-methyl butan 1 week. So butanoic acid. So 3-methyl butan, as the number of carbon 4, butan 1-week acid, butan 1-week acid, or you can write it isovaleric acid. Common name isovaleric acid. 3-methyl butanoic acid, or its general name isovaleric acid. So palmitic acid, stearic acid, then isovaleric acid. Okay. And as you know it's also very important, COH. It's also very important. This is glyoxylic acid should be written. I want to written in this way. This is called glyoxylic acid. This is also very important. Glyoxylic acid. Okay. Or you can write 2-oxo-ethanoic acid. Ethanoic acid. Why ethanoic? because the number of carbon 2. So this is ethanoic acid, and oxo means the bond is, so 2-oxoethanoic acid. So this is glyoxylic acid. Okay. So those are the very important and common examples for acetic acid, for carboxylic compound. So those are the very simple and common examples that I want to share with you. So wait for the next video. Keep studying. Thank you so much.